Section 3.5 is on operations with matrices. A matrix is a rectangular array of numbers arranged in rows and columns enclosed in brackets. This is an example of a matrix called A. It has 3 rows, and the rows go across horizontally, and it has 4 columns. The 4 columns go up and down vertically. Matrix A has three rows and 4 columns. We call it a 3 by 4 matrix. We name the rows first and then the columns, and these are its dimensions. And each element in a matrix can be described by its position in a row and in a column. So for example, the value of A sub 3, 2 is -8 because -8 is in row 3, column 2. Oh, there we go. Row 3, sorry, row 3, column 2, right here, -8. So to add or subtract matrices, you add or subtract their corresponding elements, and the dimensions of the matrices must be the same. To multiply a matrix by a scalar, that is by a constant, you multiply each element of the matrix by the scalar. Let's take a look at a couple examples. So here we have matrices A, B, C, and D, and we need to find each of the following. So number 1, we need to do A plus B. So let's just copy the 2 matrices here. So you'll notice A is a 2 by 2 that has these elements. And we're going to add to that matrix B, which has these elements. And then to get the resulting matrix, we're just going to add the corresponding elements. So my first one is going to be 6 plus 8. I'll go ahead and write these out because that's in the first row and first column, as is the 8. And then -4 plus a -1, 3 plus a -2, and -5 plus 7. So my final answer is 14, -5, 1, and 2. Very straightforward. Subtraction kind of works the same way, so I'm going to subtract matrix C from matrix B, or actually B from C, C minus B. So 8, -1, -2, and 7. So that's going to give me 4, or -4 minus 8, -6 minus a -1, which is going to turn into plus a positive, 12 minus a -2, which is going to turn into plus a positive, and -7 minus 7. For a final matrix of -12, -5, 14, and -14. And A plus D, matrix A is 6, -4, 3, -5, and matrix D, 9, 6, 0, -2, 8, 0. And you'll notice that they do not have the same elements, same number of elements. A is a 2 rows by 2 columns. Matrix D has 2 rows and 3 columns, so this is not possible to add these two. Okay, let's take a look at 2 more examples here. So number 4, and these are the same matrices we had above, is -3 times B. So this is multiplication by a scalar. So it's going to be -3 times matrix B. And to do this, I just multiply every element of matrix B times -3. So -24, 3, 6, and -21. And that's my final answer. Now my last example here is a little more complicated. I need to do 4 times A minus 2 times C. So I'll start by multiplying 4 times A and then subtract 2 times C. Okay, so that's going to give me the matrix 24, oops, sorry about that, 24, negative 16, 12, and negative 20. And a couple ways you could do this. You could either multiply by 2 and then subtract, or I'm going to multiply by negative 2 and add them because I think adding is a little bit easier. So let's multiply each of those by negative 2. And now just add the corresponding elements. It's going to give me 32, negative 4, negative 12, and negative 6. Okay. So in this lesson we looked at some basic operations with matrices, kind of defined what a matrix was and how to refer to the terms associated with it, rows, columns, elements. We looked at how to add and subtract matrices, and they must be of the same dimension, and how to do scalar multiplication with a matrix. That is basically multiply every element by the same number.